Yes. So what I would recommend is if you find for these problems like, okay, AP puts enough space to do all the work it assumes you're going to need to do. That doesn't mean sometimes you're going to go farther. You may have a less perfect way of doing the problem, but it shouldn't take up an entire page if they only gave you a quarter of a page. That's what I mean to say. So like on this problem, if I know I'm supposed to do a second derivative, rewriting this problem so I have fewer rules is always a good thing. Because keep in mind, the more rules I have on the first derivative, when I do the second derivative, they're going to compound themselves and make themselves worse. So what I would have done, and I recognize this right after we did the first derivative, because I thought to myself, wait a minute, now I got to take the next one, and I don't want to do that. So I looked back and I was like, wait a minute, how could I have adjusted this problem from the very beginning to make it a little easier? Here's how. Take this x, turn it into the square root of x squared, which in theory should be the same thing, and then distribute it into the other side. So I get the square root of 9x squared minus x to the fourth. Now this is just a chain rule. And when you do the chain of it, you end up with the following. G prime of x is equal to, changes to a 1/2 power, so we have 9x squared minus x to the fourth to the 1/2. From here, now we do the chain rule, 1/2, 9x squared minus x to the fourth, negative 1/2 times, what is this would be 18x minus 4x cubed. Like, it doesn't look much better, but the second derivative is significantly improved. And it's much easier to find. So, on these kinds of problems, like, you are always allowed to rewrite from the beginning. Like, we did that. We rewrote this as 1/2 power from the first time. That's not the only thing we could have done. So you may find, if you are looking at a problem, and it is starting to get well and truly nasty, there's probably a way you should have rewritten it. Like, there's probably a way you should have rewritten it. Like, if you looked at this problem, and you were trying to get rid of that e squared and trying to do like the product rule and stuff, and it was getting nasty because you don't know what the e is, then I'm probably going to go, maybe we need to rewrite this, or maybe we need to rethink this in a different rule or a different form to make this easier. If all we have to do is the first derivative, then for this one, the product rule is fine. But if I know I have to do the second derivative, I need to rethink how I'm going to approach this and say, how can I lower those numbers of rules? How can I go down from using a product with a chain to maybe just a product, or maybe just a chain, or something else to make this a little bit easier? Because again, I'm doing two of these. First derivative and the second derivative. The easier I make it now, the more it's going to pay off in the future. Okay. Questions on 32? Should we do it? Want to do 32? Good catch. We already have h prime. To determine the intervals of concave and concave up and concave down, what are my steps normally? And solve. If I already have the first derivative, my steps adjust. So now I take one more derivative to get the second derivative. That equals 0, solve. Okay, make sure to pay attention. This is a common thing in a problem to give you h prime instead of h because they want to save you some steps. It also makes for more interesting and unique problems. And for this problem, you could be like, I'm just doing one derivative, so a product of the chain is fine. If I was being asked to do two derivatives, I'd probably be like, nah, I'd rather simplify this now. Because then my two derivatives are much easier to do. I'd either load the work up at the front to make the derivatives easier, then load the derivative at the back. Okay. Pictured below is a function s of t. Complete the chart below indicating the sign, either positive or negative or 0 for s of t, s prime of t, s double prime of t at each indicated point. I love these questions. My favorite questions on this entire homework assignment are questions like these ones. No equations. You have to know the idea. So let's go one at a time. A. As a reminder, what is s of t?
Value.
The value, the y value specifically, right? So look at A. Is the y value positive, negative, or 0?
Positive.
Positive.
They're all positive. Yeah.
All of them?
Yeah. All y values are
All
positive.
values.
Oh, okay. It's a good thing I looked back because I thought you were saying that all three of these are positive. I'm like,
No, I said all
apologize. My brain did not process that. Okay. Beautiful. Okay. What about S prime?
At A is
At A, it's negative.
negative 0, positive 0, negative 0.
Negative, 0, positive, 0, negative. Michael, that is perfect. I didn't hear anybody else, but I'm sure you guys all got it. Okay, S double prime.
0, positive. No, it's not 0. Crap. I thought it was like this way, so.
It's concave.
So this one we have to make a guess here. Yeah, concave up is positive. So opening upwards is positive. So I don't see this like turning back. To me, it looks like the graph is continuing upwards. If you see it differently, you'd have to say so. But to me, it looks like it's continuing. I see no indication that it is leveling off here. Just that it's stopping. If it's just stopping, then I would have to assume it's concave up here.
Fair.
At B?
Positive.
At C?
Now.
Now it's 0, because this is a place where we switch from concave up to concave down. D? Negative? E?
Negative.
Beautiful. Fantastic. Love these kind of graphs, okay? Love these kind of problems. These are famous test questions, okay? And it's little stuff like that. Like we want it to switch over. But if I have no indication that it actually does, then I have to play with what I have. Could it switch? Like, you could make the argument that maybe E switches. If, it suddenly starts going this way. I don't see that. I don't have enough information to make that decision. So I have to play it safe. It should be concave down there, and A, it should be concave up. Done. 34. If, for all real numbers x, f prime of x is less than 0 and f double prime of x is bigger than 0, which of the following curves could be part of the graph of f of x? Explain your reasoning for each graph.
Which of the following curves could be part of?
Could be. So could be indicates it has to follow both of these rules. And if it doesn't, you have to explain your reasoning, so you have to say why it either does or why it doesn't. C?
Yeah.
Why do you think C?
Because it has a negative slope. The slope is defined by f prime of x, and it says it is less than 0.
So, why? It's negative slope. We can also say it is decreasing, right? That's the same thing. Negative slope implies that I have like some way to get the numbers, whereas decreasing implies that it's visual. It's a minor thing in mathematics, but like words have a very big power. If I say it has a negative slope, you assume I know what the number is. If I say it's decreasing, then you're like, oh, that means I can see it's going downwards. They both mean the same thing. They mean they have a negative first square derivative. But in the English language, they have different connotations, different ideas. Okay?
That also appears to be concave up.
So f prime, double prime is greater than 0, so it's concave up. Beautiful. This would be great reasons for why you think this one is, but make sure to clarify which of the following could be. Yes, or could be, or give some kind of indication that you do think it is. If I just do those two reasonings, like you out loud said C because, so you got to indicate that on the paper too. What about A and B?
The first one doesn't have a negative, or it doesn't decrease everywhere.
Okay, so
I'm trying to think.
So there's a mathematical way to write that, or I could write it as a sentence. Okay, the mathematical would say there exists an x such that f prime of x is greater than 0.
Yes, that.
There is also no concave.
That's exactly what it's called.
If you forget the simple stuff, like that's great to have. I'm sure Ms. Ness taught you a bunch of that stuff. But if you forget that stuff, then just write it out in words. You can't go wrong with writing a small sentence or two, or even a paragraph.
Nope, I got one else.
Okay. I think this is for all. It's been a little while. There exists some.
I'm gonna look at it. I don't even know what to look at. Math.
There's no concaving anywhere on graph A.
Actually, there is.
There is?
Yeah.
Yeah. Left.
Does that go concave down, concave up?
It looks like it, yeah. It looks like this part's concave down, this part's concave up. So what I would say is I would actually ignore both those things. Ready? If one part is concave down and one part is concave up, what do we know happens in between those two? So I would say there is a point of inflection at x equals 0. What does it mean to have a point of inflection? Well, it means that f double prime equals 0 somewhere, which automatically means this is wrong. Okay, it's a simple thing. I could say, hey, half of it is concave up, half is concave down. That's true, and also breaks that sentence. I could also say this. If I'm having to handwrite something, I'm probably going to write the smallest thing. But again, you have a lot of options for how you want to approach things. What's wrong with B?
The slope is increasing.
So this appears to be increasing. You might say f prime of x greater than 0. You might say the slope is positive. Okay. All three of those are good examples. I think there's 3 more down below. Ready? Nope, that's one. Ooh, yes! I pulled this one from 2 years ago. I love this one. The graph of a twice differentiable function is shown below. So reminders, what this terminology means. It means the graph of a function that can have 2 derivatives. It's twice differentiable means that there are 2 derivatives. So we can talk about curvature. There are some functions where there is not a second derivative. There are functions where there is not a first derivative, meaning you can't calculate slopes. You can't calculate curvature. We will see those when we come back from break and showcase what they look like. You never have to work with them because it doesn't work, but you can at least see them. All right? Order the values of f of 2, f prime of 2, and f double prime of 2 in order from least to greatest. Explain your reasoning. All right. Let's start by putting them in order, least to greatest. So let's first talk about what the values would be. So like f of 2.
0.
Yeah, it looks like 0. Remember, f of 2 means the y value when x is 2. And if you look at our picture, the y value does appear to be 0. What about f prime of 2?
Positive.
Why do you think it's positive?
Because the slope is increasing.
So that's my reasoning. Explain your reasoning. Slope is increasing. You might say slope is positive. You might say the function is increasing. In fact, if I say the slope is increasing, it sounds like I'm saying the slope values are the ones that are increasing. So you might need to make a change here to say that f is increasing. If I say the slope is increasing, that sounds more like a second derivative question. Because I'm talking about how the slope is changing. Okay? So this explains why f prime is positive. What about f double prime? Why is it negative? Concave down. So the question states to put them in order. So what order would they go in?
Least to greatest.
Least to greatest. So f double prime is negative, so it should go first. Then f of 2. And f prime 2. In order from least to greatest.
X should be 2. On f double prime. You put x instead of 2.
Thank you. I didn't even see that when you said it. I was like, what are you talking about? It's just f double prime. Thank you. It's good. Questions? 35. Love these kinds of questions. Again, questions like this one in 34 where there's no actual math to do. You have to have the idea down. These are favorites of AP. These are favorites of mine. Because you have to get the idea. You can't just rely upon, I'm going to plug into a formula. Aha! No. You have a fundamental understanding of what F prime is. What F double prime is. What F is. So you got to pull together parts of calculus, parts of algebra, to get to our solutions. Next one. Most common thing on these ones is to not actually answer the question. You may say, hey, this one's positive, this one's negative, this one's 0, but you never actually put them in order. You may say it goes in this order, but you never explain why. It's little details where you just don't do a part of the problem that are the most common points missed on an AP exam, by and far. The graph of f prime of x, the derivative of f of x, is shown in each of the following questions. Answer the questions 36 to 38 using this graph. So there's the graph. How many relative maximums does f of x have? Label these values with the letter C. Explain your reasoning. 1? That's true. It might. Usually they do not include the endpoints as answers on these kinds of questions. They don't put arrows, which is super annoying. They should. I'm sorry that your algebra teachers taught you correctly and told you to put arrows. When you start getting into calculus, they start getting lazy and being like, that's an extra step. You guys get it. It's fine. It's fine. So if I make a small change, I hope we can agree upon the solution. One of them? Where is that? The second intercept. This is my C value. How do I know that?
Because the graph is F prime.
The graph is F prime. So what does that tell me about the values in this graph? What is this? What is this? If this is say at -3, what does this dot right up here represent? No.
Where
the slope is
What the slope is at 3. So what is the slope up here at -3?
Oh, because this looks like the right prime.
Graph of F prime. Okay. So right here the slope is positive. Over here the slope is negative. Over here the slope is negative. Over here the slope is positive. Let me make this even more clear here. Negative. Negative. Positive. Positive. It's like blue is colder than red is hot. So, why is this the value of C? Where it has to have a maximum? Well, to the left of it is positive, to the right of it is negative. Do not confuse F graph versus F prime's graph. They are different.
I didn't even see the F prime graph.
Now, the mins and maxes of F prime, don't forget, are your points of inflection. Because they're places where its derivative would be 0. Here we go, 37. How many relative minimums? Label them with D.
So 2.
Where are they at?
Right there.
Have a way to describe them to me. Use your words, come on, you can do it.
Where the graph is negative from the left and positive to the right.
You're thinking too crazy. If I tell a freshman to find a point on the graph, I have Algebra 1 terminology I can tell them with.
Furthest left point on X, the X-axis.
That works. I mean, that's true. You might say the leftmost x-intercept.
Same difference.
Rightmost x-intercept.
Rightmost x-intercept would be that one. And why is that? Explain it in words. D and D. Explain.
To the left it's negative, to the right it's positive.
Beautiful. Okay. Don't confuse F and F prime. 38. Oh, I'm so glad I mentioned that. Let's see who remembers 2 minutes ago. How many points of inflection does the graph of f of x have? Label these x values with the letter E.
It's f of x.
Now. Mm-hmm. How many does it have? How would you describe them? 2? The relative max and the relative min. This would be E. So to put all 3 answers on the same picture, the maximum would occur right here. That's what we called C. The minimums would occur right here and right here, which we called D. And then we have the points of inflection. So again, C, this is a relative max. D, these are relative mins, relative min. We can call both C and D together critical values, because when the derivative equals 0. And E is the point of inflection. Point of inflection. No, this is still the graph of f prime. It said in the instructions very specifically, all of these graphs are graphs of f
I
prime.
didn't know if this one was included.
Yep, it was. Pictured to the right is the graph of f prime.
You're really aggressive.
Hey Josh, you feel like those pointing places? So you don't forget. Make it the yellow.
Oh, I got orange.
Alright,
Okay,
Actually, I think I need to be yellow.
I don't have. Do I have yellow? Want to make it go away? This is pretty tricky here.
We'll never forget.
I'm pretty sure there's some drug references up here now. Okay, whatever it takes. Okay, you got to remember these components. Okay. Okay. Okay, this is f prime. Okay, this is f prime. This represents the slope of f. This is f prime. What are the values of x where f of x has a relative maximum? 40, what are the values of x where f of x has a relative minimum? 41, on what intervals is the graph of f of x increasing? And I'll bet 42 is, where is it decreasing? So the first one, 39. Relative max.
4x equals 4.
Why? You are correct.
To the left of it, it's negative. To the right, it's positive.
So by the first derivative test.
By FDT.
First derivative test. You even go over your picture and be like, negative to positive? Wait a minute. Does the maximum go from negative to positive?
Yeah, no, it
Yes.
doesn't. But you said he was right, so it's just about to be like, okay, well, guess I'm wrong. I got to draw that. Yeah.
Okay.
Thought I did.
What the heck, Ricky?
What the heck, man?
How could you betray us all?
Wait, there's not a relative max.
So then there is no relative max.
How can you just agree?
Oh, you guys are the ones trying to run the show here. 40.
Okay, so 4 is 4.
It was 4.
New one.
Oh, now I use the first for the number first.
Oh no.
So F. Okay? On what intervals is the graph of f of x increasing? Explain your reasoning. From 4 to 5?
Yeah, because it said the slope is positive.
Good. So when x is between 4 and 5. Wait, I should probably use
Yeah,
parentheses.
interval form,
What does that mean?
Yep.
yeah.
Explain the reasoning. You said
It's social positive.
f prime of x greater than 0. I'm going to take a guess that 42 is where it's decreasing.
Everywhere else. Something like
No.
No.
Crap.
No.
Crap, there's zero.
No.
One to
No.
one.
There's
Where
one-
is it decreasing?
there's Zero.
Negative 1, 1, 1, 3, and 3 to 4. Right?
It's still
Yeah.
negative.
At 3, the value is still negative, so therefore it still has a negative slope. So therefore it is still decreasing.
That's what question 4 means.
Is that what question 4 says? I took a guess. It's been a little while. Ah! Ah! Ah!
Oh, extra work.
At what values of x does the graph of f of x have a point of inflection? Explain your reasoning.
Let's do
At 1.
At 1?
And 3.
At 3?
5.
Usually you can't include endpoints.
You can.
So,
Unless you're absolutely certain it has a maximum there. Because if you include 5, why wouldn't you include negative 1?
exactly.
Yes.
Usually you can't include endpoints unless they have arrows.
Okay.
Or that they don't clearly have a stopping place. This clearly has a labeled stopping place. Like on the previous one, the reason why we could assume it keeps going is because it didn't have a labeled stopping place. So we assume it's supposed to keep going like the edges of a graphing calculator screen. Okay? Whereas this one, they've clearly said, this is a stopping place. That is a stopping place.
I think I see arrows.
Think so? Just a little bitty?
Yeah.
I just gotta zoom in enough and I'll see them, right? So 1 and 3, I explained why those are points of inflection. That's 42. Why is 1 and 3 a point of inflection?
Relative maximum, so if we take a second derivative of that.
These are relative max and mins. Great way to start that. These are relative max and mins of the first derivative. And that's actually all you have to say. Because the relative max or min of the first derivative will become a point of inflection. I don't have to say anything about the second derivative. It's just a definition of a point of inflection. Okay, 43. On what intervals is the graph of f of x concave up or concave down? Ooh.
Wow.
Okay, take a second. Process the question
I got it.
before I go up to it. Here we go. All right, give me a second. Okay, where is it going to be concave up?
Right there.
Right there.
Yeah, just there.
Right there.
Where?
There.
Right there. You see
Negative
it?
1 to
Say again.
negative 1 to 1.
Negative 1 to 1.
It's a positive.
It has a positive slope.
Yeah.
Because the derivative has a positive slope, then the derivative of the derivative, so the second derivative, would have a positive value. That's how it fits together.
You can just ask me what
The slope of the slope generating function is the curvature. The change of the slope generating function is the curvature.
And also 3 to 5.
And from 3 to 5. This would be the increasing or concave up in this case. Where would it be concave down?
Everywhere else.
Everywhere else. Not quite. Not at 1 and 3. Okay. There's some big pieces we have kind of glossed over a little bit. We want to make sure we have really solid for our notes. And these are the connective tissue between the derivative components. So, if you have the original picture, the slope is the slope, the curvature is the curvature. If you have the first derivative, the values are the slopes. The slope is the curvature. If you have a second derivative, the values are the curvature.
And the slope of those values is jerk.
That's right. So, again, notes. How are these connect together? We have the values, the slope, and the curvature. Remember, these are all in relation to the original function f of x. So for f of x, all these are the same. The value is the value. The slope is the slope. The curvature is the curvature. For f prime, if I have a graph of f prime, the values become the slopes. Because remember, the y values of the first derivative represent the slopes of the original function. So these are the slopes of f of x. Whereas the slope of f prime represents the curvature of f of x. The curvature of f prime is the jerk. Okay?
What's the curvature?
F double prime, an undefined value. The change in the change of the change of the slope. It doesn't really have much of a use. Like there's no real physics use.
Yeah, most
And so f double prime, the values are the curvature of f of x. So these are how all three functions relate back to f of x. So if I have f prime, the values can tell me the slopes of f of x, but you can't find the values. If I have f prime, the slopes can tell me the curvature of f, but it can't tell me the values of the slope. F double prime, I can find the curvature using the values, but that's it. So if I have a graph of f prime, I can determine places where I have slopes and places where I have curvature. Remember for curvature, things that matter? So, in f prime, to find a min or max of f of x, those were located at the x-intercepts. These are critical values, right? Those come from f prime. So if you have f prime, the x-intercepts just represent the mins and maxes or the critical values. If f double prime, the points of inflection are represented by the x-intercepts. So the points of inflection of fx are represented by the x-intercepts. This is the connective tissue that pieces all of these functions together. F prime, f double prime. It allows them to talk to each other, to find components of each other. So I can use f prime to talk about the slope of the function, or the curvature of the function, or the mins and maxes of the function. I can use f double prime to talk about the curvature of the function, and use the curvature to determine other things if I need to. Find things like points of inflection. But each one connects together in that form. Always, forever. That's why it's super important to make note whenever you look at a problem, which one do you have? If I have f prime, I need to be thinking in this terms. Because in this picture, if it asks about the mins or maxes, what I'm looking for are intercepts. In this picture, if it asks about increasing and decreasing, I'm looking for values, because that's the slopes. If it's asking me about points of inflection, I'm looking for mins or maxes. And again, those represent components that could be that piece. Okay? If f of 2 equals 4, what is the equation of the normal line of f of x when x equals 3? This one, I think I typed it wrong. This would be when x equals 2. Otherwise, it doesn't make any sense. I realized that when I was working on these problems, I was like, there is an error. Okay. I know. It's a lot to ask. All right, 45. Same issue. These should be 1.9 for both these. We almost made it to the end of the homework assignment. Like, only got a couple left. How much time is it? Like a minute, tops. Okay. Okay. Use these properties to determine the following. At what values will f of x have a relative extrema? So they've given you properties of f prime and f double prime. Relative extrema can be found from either of those things. Instead of giving the picture, they give me positive, negatives, and zeros. And what values of a point of inflection? Again, same process. On what intervals is the graph of x increasing, decreasing, concave up, concave down? Again, these intervals will tell all this that. Because again, based upon f prime, f double prime's positivity and negativity. 49. Suppose the equation of a tangent line drawn at f equals x equals 2. Use it to evaluate f of 1.6 and f of 2.4. Will be the approximations be over or under? This one is a concept question. You're asked to estimate based upon what you know about derivatives. How will it be off? And 50. This one is very open-ended. Take the information you have given above and attempt to draw a graph of it. That's it. So make sure it matches every property. Where it's supposed to be increasing, it is increasing. Where it's supposed to be concave up, it is concave up. Where it's supposed to be decreasing, make sure it is decreasing. Where it's supposed to be concave down, make sure it is concave down. Ow. Just in time. Woo! Go have to sweat off the brow. Stop the video.